So I'm going to go ahead. I'm going to put this code because I'm going to let you guys work on this for like the first 10 minutes. I'm going to put the code in the chat. You don't need a space there. You have to go to student.desmoscott.com. Okay, and then you have to log in with your CCSD email, or you can just click on the, where the Google Gmail appears and it'll let you in. It should recognize your name. But let me just overview the activity here so you can see how it works. This is like super cool. I think this is very dynamic because sometimes it can get boring just looking at graphs, on a page like in your Florida curriculum book. So here's how it works. You start out going, okay, here's the water over here at the bottom. Here's the sand and here's the land on the other side. So at 0 time, what if your turtle just slowly stays real close to the water? Then you have them go at a really sharp slope pace, and then he levels out a little bit, and then he goes like that. As soon as you draw your graph and you hit play, you will see how the turtle matches the graph that you just drew. It's like super cool. You're going to want to play with slide number 1 for probably a couple minutes, okay, just because it's so much fun. Then when you go to slide number 2, I skipped 2. On slide number 2, it shows you a graph, and then you explain the story that graph would tell about the turtle. Then on slide 3, you get to play it and see if you were correct on your prediction on slide 2. You are going to absolutely love this activity. I'm going to give you guys at least 7 minutes. So till 10:10. Have fun. Okay, here's what I see to track your progress. So let me scroll down to your class. There we go. Right there. Okay, so I can see that Sophia is in, Sophie is in, Camden is in, Irene is in, Alex is in, Carolyn's in, Tay is in, Lydia's in, Grace is in, Natalie's in, Ashley's in, Isaac's in, and Sage is in. Okay, who have I not called off? Because you need to unmute your mic if you're having trouble getting in. Yeah, Alex, you're in. Ashlyn, I don't see you in yet. Are you having trouble, hon?
I'm in it.
Oh, okay. Carson, how about you? Are you starting slide 1?
I'm trying to get in.
Okay.
My internet isn't working very well.
Okay. Gwyneth, are you in?
I'm working on it right now.
Okay. I'm going to be very impressed if any of you correctly predict what happens with the turtle when you get to the circle graph. Are you guys just having too much fun? I love it. See, this is dynamic. You guys have been working with static graphs, looking at graphs on paper, looking at graphs on your screen, looking at graphs in the Florida curriculum book. But this is your first time to actually create the graphs with movement, which is very dynamic. Type your discoveries in the chat. Someone just, yeah, I want you to think about that, Alex. Why do you think that happened? And actually, I'm going to put the chat on, I'm going to put the chat on public. Okay, the chat's on public now, so you can enjoy what your classmates are saying. Oh, some of you are testing out what happens when your line is negative. What happens when you draw multiple lines on your graph? You can really explore. Taya, that's a great observation. Okay, I want some people to share. Go ahead and raise your hand if you'd like to explain why or how this happens on this graph. Why is that? Why did the turtle split according to the time and distance? Who wants to attempt that? Okay, go ahead, Sophia.
Maybe because there are two ways for him to go. So one goes negative and one goes positive, and it's just showing the different routes that he can take.
Okay, but remember what this is showing. Remember that this is showing the time since he left the water, because he starts down here in the water, and this is his distance from the water. Okay, so let me but that's a good prediction, Sophia. Gwyneth, what do you think?
I think they might have measured it 2 different times.
Kind of. I'm actually looking for something you guys have learned about linear or non-linear relationships. Think about what part of this graph is linear and what part is non-linear. Remember here, this is a certain pace. But once you hit a circle, meaning that how can you be getting closer to the land and further away from the land at the same time? Because remember, this is distance, from the water. So further away from the water, closer. The only way that could happen is if the turtle splits in half. So basically, this part in here is non-linear. Okay, it's not a function. Whereas this part here is the distance he is from the water, or she, it could be a she turtle, is going to be based on their rate of speed. So this part here gives us a rate. This part here gives us a rate. But here we've just got a split turtle because this part here is non-linear. He's flying. Someone said he's flying. Okay, I know we could get carried away playing this Desmos forever. But right now, I want you guys to refocus with me on my screen. Okay, so stop your Desmos, but you can keep the code and finish it later. And I will have a record. In fact, I'm going to go back. Nah, guys don't need any more extra credit, do you? How many of you would appreciate extra credit if you answer all the Desmos questions and you get all the way through slide number 10, which I will have a record of in my Teacher Desmos account? How many of you would like extra credit for finishing later? Okay, I will add those extra credit points in where it says IXL. So even though this is an IXL, for those of you that finish Desmos by the end of today, don't let it drag out. I will add 5 points extra credit to Module 9 IXL. And then if you also do IXL, I'll give you another points based on your SMART score. Okay, so let's everyone focus on my screen now. This is a hard deadline. What do I mean by that? Actually, there's 2 parts to this question. What does it mean March 8th is a hard deadline? And the second part of that question is, what happens if you email me after March 8th, asking what you can do to raise your grade. Okay, go ahead, Sophia.
A hard deadline means everything has to be turned in.
Yep,
At
no
that time?
exceptions. No exceptions. Not I was sick, I was this, I was that, we were out of town. Why? Because you've known all quarter long since January 6th. That's why it's hard fast. Monday night at midnight. Okay, what will I do if you email me next Tuesday, Mr. Marcus, what can I do to raise my grade? Someone besides Sophia. I would like Ashley to answer that. Ashley, unmute your mic. What will I do if you email me next Tuesday? What can I do to raise my grade?
You'll say that there's nothing you can do because all your work should have been turned in by now.
Actually, I won't even respond. But you're correct, Ashley. I'm not going to even take the time to respond if anyone emails me next Tuesday, because that is proof that you haven't been paying attention, you know, all quarter about when the deadline is. All your teachers have been talking about it. All of them have been posting it, you know, on their homepage since the beginning of the quarter. So I'm going to ignore any questions that come in next Tuesday. Okay, so here's what you got this week. I know a lot of you were amazing. Some of you turned everything in yesterday. That shows me you learned what we learned this quarter. You have an assignment for a quarter three's review on surface area. You have another assignment that's a review on volume. You have a third assignment that's a review on linear relationships, and a fourth assignment that's a review on bivariate data, which is frequency tables. This is question 4 or question 5 on all of these assignments. Make sure you pay attention to that, because if you end up, you could get all the questions above this question correct, but if you do not upload your work, you will only get a 6 out of 10 as your final grade, which is a 60%. Because your work itself is worth the final 4 points. So make sure you're turning that in. Reed, are you in here? No, Reed is not in the session right now, but he emailed me yesterday and said there was no way that he knew how to submit a picture of work from his notebook. Does anyone in the group right now not know how to upload a picture of your work from your spiral notebook? Yes, these are required. These review activities are all required. Okay, and now let's make sure that let's just do a quick refresher. We're not going to answer these because these are the actual problems on your review. And I want to make sure you do the work. But what I do want you to put in the chat right now, and I'm going to put it back to private because I don't want you to just copy your classmates. Okay, so the chat is on private. I want you to type in the chat, what are the keys to answering surface area problems? What do you have to do to be able to answer any surface area problem? Write the answer in the chat. Not the answer to the problem, but how do you go about solving surface area? Thank you, Lydia. You are correct. Thank you, Sophia Herf. You're correct. Camden, I need more detail on what you answered. Little more detail, Carolyn. Good, Lydia. Good, Taya. Good, Natalie. Sophia, do you still have your hand up? Can you put that down unless you have a new question? Okay, thanks. Otherwise, I think you have a new question. Alex, there's a trap on what you answered. I'm going to explain that in just a second. Good, Sage. Yes, Alex. The problem with the formula, Alex, it only works on the rectangular prism. That same formula won't work on like the triangular prism or on the pyramid. Yes, sorry, Irene. Yeah, you're correct. Okay, good. Here's what you guys are basically remembering. The key is on surface area, you can't really use a formula. I mean, you can on the first one. You can take 2 times the length times the width plus 2 times the length times the height plus 2 times the height times the width. And remember what's what. This is the width. This is the length. This is the height. Okay, right here. But this formula, the mistake that a lot of people make is they try to apply that formula to prisms or to pyramids, and it only works here because of the symmetry. Here you have 2 bases, but they're all triangles, or both of them are triangles. And then you have 3 rectangles, you know, here, here. What you basically have to do, and most of you are saying it, is you have to draw the net. In other words, what does the shape look like when it's unfolded? And then you add the area of each piece on the net. Okay, any questions about how to go about solving surface area? Okay, your next review, you do have to use formulas. So here's what I want you to do in the chat. I want you to give me, let me label these so you can label the answer in the chat. I want you to give me the generic formula that works for all 3 of these. What do I mean by the generic formula? I'll give you a hint. It involves a capital B in the formula. Give me the generic formula that will work for all 3 of the shapes at the top. The triangular prism, the cylinder, the cylinder, and then the cone. Yes, Lydia, you're correct. Yeah, Natalie, on the final, you have to submit your work. Alex, you are correct. I only have 3 people that know. Sophia Herf, you're correct. No, Natalie, you're giving me a specific one. You're giving me a specific one, Camden. The generic, meaning it'll be the first step for any volume solid other than a sphere. It doesn't work for the sphere. Yes, Natalie, good. No, you're already breaking it down, Camden. Some of you are jumping to the second step. Sage, you're already giving me the second step. No, you don't have to do a net for volume. Okay, here's what I mean. Volume on all 3 is capital B times little h. Now, here's my next question. What does capital B represent? Type that answer in the chat. What does capital B represent for any shape you want to do the volume of? Yes, Ashley, Sophia, Sage, Gwyneth. Good. Good, Irene. Good, Sophie. Yes, B stands for base. Okay? B stands for base. So what you have to do is you have to substitute for B. So in this first one, notice that the base, because you have to think about standing this up, so that it would be standing up like this because it has two opposite bases. So this base is a triangle. So you would do the area of the base, which is 1/2 of little b times h, and then times big H. Okay, which is, so this would be 1/2 of 10 times 12 times big H, which is 16. So don't confuse little b, which is 10, with big H, the height of the standing up prism. Okay, the capital B on this one is a circle. So when you substitute for capital B here, the area of a circle is pi r squared, and then times the height. So you're going to have to take pi times 6 squared, because diameter is 12, the radius would be equal to 6. And then on this one, this starts out the same, pi r squared h, but what else do you have to remember that is your starting coefficient on cones? What goes in front of the pi r squared h on a cone? No, not 4/3. This is a cone. You're thinking of a sphere, Sage. Yes, 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 Isaac. Yes, Sage. Yes, Irene. Yes, Sophia. Yes, Anderson. Yes, Taya. Yes, it's 1/3. Now, for this one, what is the formula for finding the volume of any sphere? What's the formula for finding the volume of any sphere? This one is the hardest one to remember. More than that, Isaac. You got the first part, Isaac, but I want the whole formula. Good, Sage. Good, Sophia. Good, Irene. Taya, you almost have it, but it's 3D. It's not 2D. So it's not squared. Yes. Good. So this one is volume equals 4/3. And to type it into the chat, you'd have to put pi because you don't have the pi symbol. So pi r raised to the 3rd power, or you can just spell out r cubed. That little caret symbol there, which you can find on your keyboard up by the number 6, this little symbol here means raised to the 3rd power. Okay, so that was the second thing we learned this quarter, was volume. Okay, here's the third thing. Now, I'm not going to have you answer these right now, except for this question. How do you submit a scanned image of your work if you have equations or graphs? How are you going to submit a scanned image of your work? Because I know some of you turned this in yesterday and you said it was all mental. Not quite. Because it says if you use mental math, you still have to explain your thinking. You can't just submit the answers. So how do you do these kind of problems and show your work? Yes, absolutely. Use graph paper. That's step number 1. Now, how are you going to explain your work if you're finding the slope of a line? How are you going to show me that you correctly did the slope? Well, slope-intercept form only gives me the answer. How are you going to tell me what the slope is from this point to this point? Yes, you use a graph, but what are those 2 words? Those 2 important words that both start with an R? and I demonstrate it with loop-to-loop? Yes, rise over run, exactly. So how do you show that? On your graph, you're going to go, I went up this many, and I went over, and I'm going to stop, or I'll be giving away the answer. But there are ways to show your work. Don't just give me the answers. Wow, you guys are going to ace the test next week. You guys are more than prepared, so I have no problem letting you guys out early. Okay, now for your exit ticket. Okay, so let's see how well you were paying attention today. Which example of the given turtle paths was an example of a non-linear relationship? Put your answer in the chat. Okay, so Irene, you are correct. You are dismissed. Camden, you are correct. You are dismissed. Taya, you are correct. You're dismissed. Camden, you're correct. You're dismissed. Irene, you're dismissed. Yes, Sophia, Herf, you are dismissed. Thank you for all your participation today, Sophia. Alex, you are correct. You are dismissed. Lydia, you are correct. You are dismissed. Ashlyn, retype that. I can't read that. Sage, you are correct. You are dismissed. Isaac, you are correct. You are dismissed. Camden, you are correct. You're dismissed. Irene, you've gotten it correct like 4 times. I just can only go so fast down the chat. Yes, Ashley, you are correct. You're dismissed. Taya, you're welcome. You're welcome, Alex. Thank you. You're welcome, Sage. Thank you. Yes, Ashlyn, you are correct. Carolyn, I don't see your answer. Carolyn, I don't know. You're giving me a name. I need the path, not the name of the person. You guys, the name, the shape of the path, the turtle's path that represented a nonlinear relationship. Gwyneth, you are correct. You are dismissed. Yes, Mackenzie, you are correct. Okay, for you, those of you that are still there, it was the one where he went like this, then you had a circle, and it went like this, and the turtle split in half. That was an example of a non-linear relationship. Thank you guys so much for your attention. Study hard, complete your reviews, show your work, and I'm sure you guys will do great. Okay, you guys have a great rest of your week. Take care.